Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Amirul bin Baharudin, and today I will present about the topic for engineering laboratory 6, which is bending of beam, topic 3 in the lab module. So I will present about the additional theory for this topic. Okay. Basically, beam is a structure that primarily resists loads applied laterally to the beam axis. For a beam to remain in static equilibrium, when external loads are applied to it, the beam must be constrained. To find the shear force and bending moments over the length of a beam, external reaction at each constraint need to be solved. The external reaction should be balanced the applied load such that the beam is in static equilibrium. After the external reaction have been solved, second cuts need to be taken along the length of the beam and solve for the internal reaction at each section cut. So basically, this is the diagram for cantilever beam. You can see the arrow for the moment, bending moment, and the force. So basically, there are type of uh, which is pin uh, beam with uniform load, pin fixed beam with uniform load, and fixed beam, which is fixed constraint, and pin beam. We example to find bend moment and force following this. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Ahmad Islam bin Ahmad Zohari, will be representing Group 2A for the slide presentation of the test result and observation. So look at the result. This for the first result, the relationship between load and deflection. This is the result for the second experiment, which is the relationship between fan and deflection. And finally, the relationship between height and deflection. Now let's go to the observation. For the first test, we can see that uh, there is we are taking note about the difference of load and deflection, and as the higher the load value, the higher the deflection. For the second experiment, we can see that we use different length of span length, and the longer the span length, the bigger the deflection. And finally, we can see that we use the different dimension for the test specimen, and we can observe that the bigger the dimension, the lower the deflection. Thank you. That's all from me.
Next, I'll present about the calculation. The first calculation is on the modulus Young. Firstly, we calculate second moment of inertia using BD cube over 12. And then for modulus Young, we use equation y equals to WL cube over 48 Young's modulus and second moment and inertia. Next. We compare the modulus of elasticity obtained with the theoretical value. Um, uh, to get this, we minus theoretical value with experimental value, and we divide it with theoretical value and times it by 100%, and then we get the percentage of difference of theoretical from experimental. For the last calculation on center of graph, the first graph of deflection versus load, we calculate its centroid for x and y coordinate, which on x coordinate, we add 5, 10, 15, and 25 of the load, and we divide it by 4. And for y axis, we take 0.23, 0.52, 0.76, and 1.05, and we divide it by 4. And then we get the centroid coordinate for x and y, which is 12.5 Newton and 0.64 millimeter. For the second graph of deflection versus span length, the center on x-axis is we add 300, 400, 500, and 600, and we divide it by 4, and we get 450 millimeter for the span length. And for the deflection, we add 0.07, 0.14, 0.35, and 0.56, and we divide it by 4. Then we get 0.28 for y coordinate. And then the center of graph for deflection versus span length is 545 milliliter and 0.28. For the second graph of deflection versus specimen height, the centroid for x-axis, x coordinate is we add 4, 6, and 8, and we divide it by 3, and we get the specimen height. For y coordinate, we add 0.46, 0.16, and 0.05, then we divide it by 3 to get 0.22 mm for y coordinate. So the centroid coordinate for third graph of deflection versus specimen height is 6 millimeter and 0.22 milliliter for y. That's all for me. Thank you.
Assalamualaikum. So today I'm going to talk about the discussion of bending of beam for my group. So we got three different graphs. First, graph deflection versus load, graph deflection versus span length, and graph deflection versus height. So first graph showing that y is proportional to p, and second graph also showed the same pattern graph, y is proportional to l, and the last graph. Based on the graph deflection versus height, show inversely proportional graph pattern on deflection and height, because based on the equation after we derive, we got y is inversely proportional to d. Okay, so for the next question is the importance to have several type of beam. So there are advantages and disadvantages to if we use different kind of beams. So different type of loads will be applied to each of the beam used. So the shape and cross section of the I-beam makes it stronger than other types of beam as shown in the example. Also, an I-beam can be utilized to support its weight and load. Commonly, use frames or a protective edge wall RC channels. As a result, I can deduce that beams come in a variety of shapes, sizes, and materials. There are different ways to choose a beam.
Hello, my name is Ahmad Sirahan bin Ahmad Safwan. My metric number is AD180099. I'm from Group 2A. So today I'm gonna present about the conclusion. For the conclusion, the relationship between the deflection and the applied load is determined. The deflection increases when the load increases while keeping the span length and test specimen dimensions same. The deflection also increases when the span length increases. However, the relationship between height and deflection shown the deflection decreases when height of test specimen increase. Next, there's some problems occurred during the experiment. One of the problems that occurred during the experiment is the deflection of the beam, as shown by the gauge, is fluctuating after the load is added on the hanger, which this make the exact reading of deflection of beam is hard to be recorded. For the recommendations to overcome the problems that occur during the experiments, first, Try not to shaking while doing the experiment. Next, the experimental apparatus also should be in good condition before conducting the experiment. That's all. Thank you.